checkpointing and some backup. That was the only rescue that we had. Okay, and then we have data node. So data node is like there is not much of the change. So they were just acting to just give the data blocks in it, right? Not much of the change from one to the latest version. There's not much of the change in the data node. Uh, there was a component which is known as job tracker. So job tracker is kind of a master which was responsible to perform a lot of work, right? So in Hadoop one, job tracker was something which was performing a lot of things. Like it was responsible to get all the input requests, right? So usually if let's say I want to submit some job into the cluster, so any request to do any operation, it was going through the job tracker. Okay, and job tracker was getting all the intake request. It was distributing that request into the small task, dividing it among all the workers. And job tracker was also responsible to do the monitoring, right? So let's say, for example, let me just very briefly tell you what the job tracker. So let's say there are 100 clients or 100 users. Each one is submitting one job. Okay, so total I have 100 job requests which goes to the job tracker. Now this job tracker was responsible to do everything. So the first thing that it was doing is, for each job, break down them to smaller tasks. Okay, and what are the tasks? Mapper or reducer tasks. Any processing, it goes through mapper and reducer. So okay, we will learn that. So first thing was like you get all the intake request and then you break down into a smaller task, and then the second responsibility was distribute it to all the workers. And in prior version, those workers were known as task trackers. Okay, and not only this, it was also responsible to do all the monitoring of all the tasks. So let's say, for example, each job is divided into 5 tasks, for example, right? So 100 into 5, 500 tasks was to be monitored by the single job tracker. Okay, what sort of monitoring? Look whether it is running or not, to get their progress. If it failed, go and restart it somewhere else. So if you really look, this one particular job tracker was kind of doing a lot of work, and if something is doing a lot of work, it means it will definitely get bottlenecked, right? So you cannot run, you like, till 100 job it is fine, till 1000 job it is fine, but if it goes more than 4000, 5000, right, and assume each job is having so much of tasks, right, which will run into 50,000, 60,000 tasks. So one process cannot handle everything. And this was one of the greatest and biggest challenge in the Hadoop one. The job tracker was getting bottlenecked. Okay, and the scalability was the biggest issue. So, and also the second challenge was, so first thing was bottlenecked job tracker, and second biggest challenge was about single point of failure. Okay, now if one person is doing every work, assume in our project, right, if one person is doing everything, all the work, let's say he is getting all the input requests from all the customers, and he is performing the coding, testing, deployment, everything, then there will be some limitation, right? If one person is doing everything, he cannot take more than some certain number of the tasks. And second challenge is like if that person goes on the leave, or he is having some, he falls sick or something like that, it means no work can happen in the project, right? So the same challenges we had with this Hadoop one also. If job tracker is not working, it means everything is down. So all the existing task will fail. You cannot submit a new task. It means you cannot do, ideally you cannot process any data. Right, so all these were the challenges with Hadoop one. No, job tracker is not similar to Uzi. See, job tracker was responsible to do all of these things. Like Uzi, Uzi is a workflow. Okay, Uzi is a workflow. What do we mean by workflow? It means I want to run first. I want to run a sales script. First step, and step number two, I want to run scope job, for example. Okay, and step number three. So, and it will maintain this type of workflow. Okay, first step is run a shell script, any shell script. Second is run a scope. Third is run some hive. Four is, and after that you run for map reduce. So that is what Uzi does. Okay, job tracker don't do all of these things. Job tracker only deals with this work, any map reduce processing. So within this, if you submit a map reduce job, then the job tracker will come into the play and it will divide the work into all these nodes and all of these things, right? So Uzi is at a bigger workflow, and anything which is happening within a map reduce, it was taken care by the job tracker. Okay. Yes.
Dheeraj, when you talk about a name node and secondary name nodes,
Hmm.
is it like, are you referring to single machine, like single computer or something?
No, no, both are different.
Like
Two
it's
different.
not like a name. I mean, secondary name node will be on is installed on a single computer. It's not like that, right?
No, 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 both has to be different computer.
Now both has to be different, but a single computer to be assigned for for differently for both of them.
No, 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 two different computers. See, if you look over here,
No,
this is name node, this is secondary name node, two different computers.
it's a cluster of computers or a single computer.
A part of the cluster only.
Okay. Okay.
Okay. See, all of this thing is part of the cluster. So for example, let's say my cluster has 10 nodes. Okay, what I'm going to do, node number 1, I'm going to make it as a name node. Node number 2, I'm going to make it as a secondary name node. Okay, node number 3, I'm going to make it as a data node 1. Node number 4, I'm going to make it as data node 5, 2, and so on, right? So that's how you make your cluster. Right, so that's what it is.
Make two computers as name nodes. Like my name node will be having two computers, two nodes.
Now your name node is one node. See, node 1 is your name node. Only one name node in
Okay,
only see one node. Node number 1 is dedicated for name node. Node number 2 is dedicated for secondary name node. You don't have two nodes for the name node. One node for name node, another node for secondary name node.
got it.
Okay. All right. Now let's talk about HDFS high availability. Okay. So high availability is usually a solution which has been offered in Hadoop 2 to ensure, like, even if name node fails, it is not bringing down the cluster. Okay, so what we have, instead of having one name node, we'll be having two name nodes. One will be active and another will be the passive. Now if you look into this, and this is a quorum based shared storage. So quorum is something where you store your data in a distributed environment, something like this. So you dedicate some of the nodes, and these are known as the journal nodes, okay, which could be part of your data node. So data node can serve as the journal node. So what we are going to do is we are going to commit the changes into a quorum of the nodes. So say for example, I have a cluster like this. So I have some data nodes in it, and then I have two name nodes. So one will be acting as active, second will be working as a standby name node. So standby will just be standby, it will not do any work. Okay, it will not serve any request. So any serving of the request will always happen through the active name node. Okay, the only work for the second standby name node is to ensure it is in sync with the active name node. That's the only work which the standby will do. And what sort of sync? So any changes which is happening in the name node. What are the changes? So if you recall, we were talking about edit logs, right? So any changes which is happening in the file system, those changes will be recorded in this cluster of the journal nodes. Okay, so journal node is, let's say you have dedicated three nodes and which is storing some information. So active node will be pushing all the changes into these nodes, and standby will be downloading all the changes and making itself in sync with the active name node. Okay, so for example, I have 10 files. I added the 11th file. So the 11th file information will go through the active name node to the journal nodes, and the standby will come to know, okay, some changes has been made. So it will download the information and it will keep itself sync, and it will also come to know that, okay, 11th file has been added to the file system. And there is a concept of failover. So whenever there is an issue with this name node, right, this one crashes or it is down, automatically the failover will happen and this one will become active. And since it is already in sync with the active name node, so it can serve the request without any issues, right? Because it will have all the information what is required. So it will have all the information like which file is present where the blocks are present, where the replicas are present. So entire information will be in sync between active and the standby nodes. And over here also there are two different nodes, not the same node, right? Two different nodes. Any questions?
Whereas this syncing process will be a real-time process, or it will be done over the night, or will be scheduled sometime.
It will be real time.
Okay.
Okay. So let's quickly go through each of the components. Name node, as we discussed, it is something which stores the metadata, right? And what is the metadata? It is information about the file system. So it will say like how many blocks are there for a file, where each of the blocks are present, all those information, right? Where the replicas are present, all the entire metadata will be stored in the name node. Okay. What is a data node? Data node is nothing but a component which stores the actual physical blocks of the data, right? So if I have a file which is broken down into 5 blocks, so all those blocks will be stored on the data nodes. Okay, and where exactly we store this data node? On the racks. What is a rack? Anyone? Like what do we mean by a rack?
It's just a
You mean
classification.
each data node?
No, data node is
All the nodes on the cluster.
all the nodes in a cluster is not a rack.
Rack is
No, each rack.
Each rack.
a physical rack is a physical unit which stores all the machines. I mean that's a general, but if you ask for storage, then it's a collection of either LAN or SAN or any storages put together into the network access.
Absolutely. So rack is it's nothing but we are grouping the nodes together and giving it a name. See, rack. Let's say I have 10 nodes, right? So what I'm going to do is first five I'm going to put in rack one, and second five I'm going to put in rack two. So it's nothing but just a group of the nodes. So rack one, what it will contain? It will contain node one, node two, right, till node five, and rack two will have node six till node 10. Right. So what we have done, we are just splitting up the nodes into different racks. And once you combine multiple rack, that becomes a data center. And what we'll have in a data center, we'll have racks. Let me show you some diagram. So this is one of the data center of Yahoo. Right. So something like these are the nodes, right? So we can have multiple nodes, and that we can put in a rack, right? And once we combine multiple racks, so that becomes a data center, right? So that's what it's nothing but a group of nodes put together in a hardware. So that represents a rack. It's nothing but a group of nodes. So rack concept is important in Hadoop to understand, because while replicating the data, we learn that it replicates across the rack as well. Not only the nodes, but across the rack as well. So let's have a look.